So, very good morning to all. Respected distinguished speaker of today's session of Advances in Waste Management System, Dr. Sunil Pandey, sir. Sir, we welcome you on behalf of ADIT Patel Institute of Technology, Department of Mechanical Engineering. All participants of this particular STTP, which is sponsored by the Gujarat Council of Science and Technology. It's a joint venture of Department of Science and Technology. Sir, I request first our principal, sir, Dr. Vishal Singh, sir, to give the blessing before we start the STTP. Sir, Vishal Singh, sir, you are requested to give the blessing.
A very good morning and greetings to all. I welcome Dr. Pandey and the participants. The topic on which the STTP has been organized by Mechanical Engineering Department under Dr. Mitesh Shah is a very important topic in today's context. We as human race have been consuming resources at an immense rate, and in the process we are producing waste of various kinds. Now, disposal of this waste in a green and sustainable manner is a challenge before us. Now, this waste can be a municipal waste, agricultural waste, biomedical waste, industrial waste, and of various types. Depending upon the nature of the waste, appropriate technologies need to be used to dispose these waste and try to convert them in the best possible form. I hope over next 5 days, all the participants will get different views and knowledge on these topics, which would add to their knowledge bank. I wish this program a great success. Once again, greetings to all from my side. Namaskar.
Thank you, sir. Thank you for your kind words. Before we start the session, I would like to introduce our today's speaker, Dr. Sunil Pandey, sir. Dr. Sunil Pandey, sir, is a Senior Fellow and Director, Environment and Waste Management Division, the Energy Research Institute, TERI. In addition, he is an adjunct faculty at the TERI School of Advanced Studies. He has more than 25 years of consultancy, research experience in the areas of municipal waste, industrial waste, and hospital waste management. He has also having experience in plastic waste management, waste to energy issues, air, water, and soil quality monitoring, site assessments, performance evaluation of ETP, and institutional strengthening and capacity building. He has obtained his PhD degree in hazardous waste characterization from Nagpur University while working as a project fellow at NERI, Nagpur. He has MSc Analytical Chemistry from BHU, India, and did his BSc Chemistry also from BHU. Prior to joining TERI, Dr. Sunil has worked for ERM India as a consultant for 2 years, where he was working on projects related to hazardous and hospital waste management, environmental site assessments, and institutional strengthening and capacity building. Dr. Sunil Pandey has also worked as a research assistant at Hong Kong University of Science and Technology on development of landfill liner for containment of land disposed hazardous waste, and University of Hong Kong on deriving material balances and associated environmental pollution for Hong Kong region as a part of his postdoctorate fellowship. Sir, looking to your biodata, it's very rich biodata. We will be very happy to have with us. I request Dr. Sunil Pandey sir to start his presentations. We had a good number of participants from across the Gujarat. Many of the participants are outside of the Gujarat also. Sir, I request you to start your speech. Thank you.
Thank you, and let me begin with thanking Professor Singh and Professor Mitesh Sai and Professor Thakkar, and also overall ADIT and Gujarat Council for inviting me for this lecture. Let me start sharing my presentation. Let me know if you can see this. Can you see the presentation now?
Yes, sir. Yes, sir. Now it is visible.
Thank you. Initially, when I was preparing this presentation, I was looking at health sector and waste generated in health sector, and I thought I'll include both biomedical part of waste and also hazardous waste part of waste. But I mean, then I ran into too many slides. So let me see. Primarily, since the focus is on biomedical waste management, I'll cover biomedical waste management issues. If the time permits, I'll slightly touch on hazardous waste as well. And why, I mean, these two streams are very important when you're looking at hospital waste is because there are various assessments. So if you look at healthcare facilities, there are various assessments, especially the most remarkable one by WHO, which says that in a well-managed healthcare facility where all the waste is managed in a proper manner, around 85% of the waste is municipal waste. And around 10%, basically 75 to 80% is municipal waste, fluctuating the percentage. And around 10 to 15% is biomedical waste. And 5% is hazardous waste. So key to management of biomedical waste is if you don't want this percentage of biomedical waste to go up, when the waste is generated, you need to basically segregate and store them in a segregated manner so that they don't get mixed. Once waste is mixed, it's true for hazardous waste as well as biomedical waste, then the entire lot has to be treated as biomedical waste. So you can understand why I mean waste segregation at source and storage in a segregated manner is important to keep the quantity low and manageable, and which will actually become clearer when we go through these slides further. Most important issue, if you look at, we will start from regulation. What is the regulation which is dictating biomedical waste management? And the first, since I've written here biomedical waste rules 2016, the first time biomedical waste rules were notified in the country was 1998. And you'll be surprised, I mean, the biomedical waste rules actually were notified before municipal solid waste. So that shows, I mean, how much importance was given to biomedical waste just because of the infectious characteristics of biomedical waste, that the rules were notified earlier than municipal solid waste. And gradually, rules underwent modification and re-notification. Finally, in 2016, in fact, not only biomedical waste rules, but all the waste rules, the 6 of them, including municipal solid waste, including electronic waste, including hazardous waste, including construction and demolition debris waste, were all notified in 2016, basically to harmonize these rules and also to bring clarity to not only authorities who are supposed to manage them, but also the entities who are generating these waste, to bring in clarity on what is the role and responsibility of different entities and stakeholders in management of these rules. So this is what is actually expressed in these slides, which I'll go through one by one. Biomedical waste rules, as I said earlier, the latest ones were notified in 2016, and all these rules actually are notified under Environment Protection Act, EP Act, in short, we say, which is an umbrella act for all these rules, and this was initially notified in 1986. Since 2016, these rules have been amended in 2017, 2018, and latest last year, 2019. Some minor changes have been brought in these rules to make them more effective for implementation. Now, to begin with, I'll start on to which entity these rules are applicable. So, I mean, if you look at this long paragraph in this bullet, important aspects are generation, collection, receiving, storing, transporting, treating, disposing, and handling. All these issues need to be carefully monitored, carefully carried out from the organizations such as hospitals, nursing homes, clinics, dispensaries, veterinary institutions, animal houses, pathological laboratories, blood banks, Ayush hospitals. Some of these were not included earlier. For example, Ayush hospitals or veterinary hospitals were not included in rules earlier. Now the rules are much broader and include all these establishments as well. Clinical establishments, research and educational institutions, health camps is again a new entry, medical or surgical camps, vaccination camps, blood donation camps, first aid rooms for the schools, forensic laboratories and research labs. So that shows that almost any entity which is in some way or other into vaccination or treatment of the patients, or even research and development on infectious material is covered under biomedical waste rule now. Now, every rule, especially when you look at all the industry-based rules, for example, hazardous waste or electronic waste or biomedical waste rules, there's an entity which is called occupier. What occupier means is the entity which generates the biomedical waste. So in this case, for biomedical waste rules, it will be hospitals, healthcare facilities, but blood banks, or pathological laboratories, all such entities which were identified earlier are occupiers. They, in the process of treating patients or carrying out certain activities on research and development, will be generating this waste, and these are called occupiers. So what is their responsibility under the rule? Collection of biomedical waste in specified bags or containers. As there's a schedule 1 appended to this rule. So as per that schedule, they need to, which will come to the schedule later, they need to collect the waste as specified. To be transported after collection directly to, there's something called the CBWTF, stands actually for Central Biomedical Waste Treatment Facility. It's a common biomedical waste treatment facilities which are established in all the states now. Depending on amount of waste generation, there can be more than one common biomedical waste facility in the state. And they need to be transported in a manner that it prevents manual handling of waste, because unlike municipal waste, this is much more hazardous and infectious when we talk of biomedical waste. Sometimes there's a requirement of pre-treatment of bioactive waste. Bioactive waste, say, for example, something which can cause hepatitis or viral infection or bacterial infection. They need to be pre-treated at the source of generation. And there are guidelines provided by WHO and NACO. NACO is AIDS organization. And before they are sent to this common waste treatment facility. Importantly, earlier rules didn't mention anything about chlorinated plastic materials, because what happens is in healthcare, we use a lot of chlorinated bags, plastic bags and other materials, tubings and etc. Because chlorinated bags and tubings, they last longer and they are much they are much cheaper to produce. But in this rule 2016, there's a timeline for phasing out of this chlorinated plastic material. For the reason that why we need to phase this out, because as a treatment, when you burn these plastic materials, if they are not recycled and they have to be burned, then they can generate a lot of toxic fuel, toxic emissions in terms of dioxins and furans, which are very toxic to human beings. So there's as a good intention, chlorinated plastic bags should not be used for urine bags, effluent bags, abdominal bags, and chest drainage bags. This was as per latest amendment in 2019. The healthcare facilities, all those who are in the process of generating healthcare waste, need to establish a barcode, much like you use Paytm, you use those other online payment methods. These facilities also need to establish their individual barcodes, so that once a waste is generated, and all the containers and bags should have this barcode, so that from the bags and containers it can be identified in case one needs to identify from which facility this waste has come. Then occupier also needs to provide training, immunization, and regular reporting of status of biomedical waste generation to the State Pollution Control Board in the state where they operate. There has to be separate collection of solid and liquid waste streams. Duty of other than occupier, which is generator of biomedical waste, there is also duty prescribed in the rules for the operator of common biomedical waste treatment facility. They need to provide timely collection of the biomedical waste which is generated, because of the very infectious nature. It has to be upon generation. It cannot be stored beyond 48 hours in a facility, and it has to be collected and transported to common facility. Timely collection, also barcoding, helping the generators also in barcoding and generating their barcode. GPS system, GPS-enabled system for transportation. They need to establish all this within 1 year of notification of biomedical waste rule, which were notified in 2016. To take authorization for collection, transport, storage, treatment, and disposal of waste, and operate treatment facility accordingly. This authorization has to be taken from State Pollution Control Board. Again, in the state where they operate. Training, capacity building, and providing need-based support to occupiers. In the sense that if occupiers are smaller facilities, say for example, smaller pathology lab or smaller blood bank or a smaller, institutional facility, then if they require some training and capacity building, the common facility operator has to provide them training and capacity building also, of course, on a fee. They can do that on a fee basis. Maintain records of recyclable waste sold after disinfection. This is something which is very new to biomedical waste rule, because if you look at earlier notifications, they were not allowing any recycling in the biomedical waste facility happening. Because of the fact that we all know that biomedical waste are infectious waste, and if there is any recyclable material, say blood bag or tubing or IV sets or glass bottles even, unless they are cleaned properly, unless they are disinfected properly, there's a risk in recycling. A lot of illegal recycling activity used to happen earlier. So, knowing that recycling is still happening, this mandate in the rule came that recyclable waste, if they can be disinfected, and if they are stamped for disinfection, then they can be recycled. Handling and disposal of mercury and lead waste, because sometimes the treatment facilities also generate mercury-bearing waste. For example, blood pressure equipment or thermometer which has mercury, or other chemicals for dental amalgam, you use mercury. Lead also is used in treatment process. So they need to be basically handled as per applicable legislation, which is hazardous waste legislation. So any mercury and lead bearing waste has to be treated as hazardous waste legislation. Now, to treat infection, what is a treatment standard which is prescribed for the common facility? Sterilization to log 6, if the sterilization is the primary method of disinfection, or if chemical disinfection is happening, or steam disinfection is happening, then disinfection to log 4 required for bioactive waste. No occupier to establish treatment and disposal facility if there is a common facility existing within 75-kilometer radius of the healthcare facilities. This is to just to ensure that whatever facility has been created is utilized at its optimum capacity, and there's an optimum capacity utilization of biomedical waste treatment. Now, as I said, there are the waste which is generated has to be basically managed as per Schedule 1. What Schedule 1 prescribes is there's a table which you can see, and there are different color codes and bags and containers prescribed for different color codes. For example, and what type of waste can be stored in this bags or containers is prescribed, and also what would be treatment option, treatment and disposal option for these bags and containers. Yellow bag, for example, would contain human anatomical waste, and I'll not go through this description. You can go to this. Yellow bag should be yellow colored and non-chlorinated, because as I said earlier, yellow bags are destined to go for incineration or combustion process, or either by incinerators or by plasma pyrolysis, or sometimes in rural areas, if incinerators in the smaller facility is not available, they can be also disposed in that case as deep burial, which I'll discuss later, how a deep burial should be done. Similarly, animal anatomical waste, like human anatomical waste, should be stored in yellow bag. Solid waste, those items which are contaminated with blood, body fluids, etc., should also be stored in yellow bags. And treatment process again is incineration or plasma pyrolysis. But in case, if these facilities for some reason is not available, say for many hospitals, larger hospitals also provide captive treatment, then they need to be autoclaved or microwaved, so that they are disinfected completely before they are sent for disposal. Similarly, category D in this yellow bag is expired or discarded medicines, because many times medicines are in most of the healthcare facilities, medicines are ordered in bulk. Sometimes they are used in time, sometimes they get expired. So they also, once they become expired, if the manufacturer is not taking them back, if there's no buyback arrangement, buyback in the sense, sometimes manufacturers take them back, sometimes they don't, depending on quantities. They need to also go into yellow colored non-chlorinated bags or containers. And they need to be essentially incinerated, because they, as a medicine, they can produce a lot of hazards which are not known. Especially there are certain kind of drugs like cytotoxic drugs, which can create problem with your genetic makeup. They need to be incinerated because they are too dangerous to be handled otherwise. And incineration conditions, which is mentioned, is at greater than 1200 degrees centigrade in the incineration facility or plasma pyrolysis. All other discarded medicines, if there is an arrangement, they can be sent back to manufacturer for disposal. Again, manufacturer has to dispose it by incineration. Category E, chemical waste. Chemical waste which is discarded, say discarded in treatment process. Many times we culture cells and use biological medium, certain disinfectants. They also need to be collected in yellow colored bags and disposed by incineration or plasma pyrolysis. Category F, chemical liquid waste. Chemical liquid waste is generally, generated from facility in the healthcare facilities like you have pathological laboratory, you have X-ray section, you have blood test section, where a lot of chemical liquid waste is generated. That is not to be mixed with solid waste which is generated in healthcare. As I said earlier, the rules prescribe that solid and liquid waste has to be treated separately. And every hospital now, and every large healthcare facility now has to install a effluent treatment system, and to which this chemical liquid waste should be going. And there's a prescribed standard on how the chemical waste has to be treated in ATP, effluent treatment plant, and they need to conform with the standards which are there in Schedule 3 of the biomedical waste rule. Now, what happens is, for example, if you are a small facility and you don't have capacity to install ETP, then you need to generate all the liquid chemical waste into a drum or a container, which is not reacting with the waste which you generate. And at suitable time, when enough volume is there, that has to be given to common waste treatment facility. And you need to basically have a contract with common waste treatment facility. As and when sufficient volume is there, they need to be sent to this waste treatment facility. There are waste types, say for example, if you look at category G, discarded linen, mattresses, beddings, which in healthcare facilities will be, there is all possibility that they will also be contaminated, because anyway, treatment of human beings is going on. They also need to be stored in non-chlorinated yellow plastic bags. Now, what happens is sometimes these mattresses, linens, bags, beddings, they are huge in size, they are large in size. So how do you store them in bags? So if hospital has a pre-treatment facility, they need to shred them into smaller pieces, and then these smaller pieces can be packed in containers or plastic bags. If you don't have shredding facility, then they need to be just closed in such a packing material, and which doesn't interact with the environment and which doesn't leak anything from this packing material. And then it goes to common facility for disinfection, followed by incineration or plasma pyrolysis for energy recovery. Now, energy recovery also for the first time has been prescribed in rules for 2016, because there's a possibility of recovering some energy in the incineration process or plasma pyrolysis, burning the high calorific value waste. Category H is typical waste generated from laboratories and clinical facilities. Microbial biotechnology and other clinical laboratory waste. What is to be done with them? They need to be disinfected by autoclaving as a pre-treatment, and then sent to either common waste disposal facility. And as I said earlier, the treatment process needs to be followed as per the guidelines of NACO or WHO. And then at the end, it has to be incinerated. Now, these are the waste categories which have to be basically packed in yellow bags and essentially going for incineration in the end, or pyrolysis and burning, because these are very infectious waste and they cannot be otherwise disposed at the common waste treatment facility. Then there are waste categories which can be recycled if they are properly disinfected. They need to be packed in red bags. And for your information, now in COVID times, when we are generating a lot of these masks and coveralls and PPEs which are used in COVID management from the camps and from the hospitals. They also essentially, as per rules, CPCB subsequently this year has come out with guidelines that they also need to be packed in yellow bags and finally go for incineration. Red bags, what they need to contain, or what is to be packed in red bags? Contaminated waste, for example, waste generated from disposable items like tubings, bottles, intravenous tubes, catheters, etc., which are generally either glass or plastics. They need to be packed in red-colored, non-chlorinated bags or containers. And treatment procedure which is prescribed is autoclaving or microwaving. Sometimes there's a version of autoclaving which is called hydroclaving is also used, followed by shredding or mutilation of waste. And then they can be, after shredding and mutilation and complete disinfection, they can be then sent to authorized recyclers. There are authorized recyclers who need to take authorization from State Pollution Control Board, either for recycling or for energy recovery. Where, I mean, when you say energy recovery, they can be used also as a fuel because of high calorific value, if they cannot be recycled. And as a caution, now since you know that plastic has become a problem, global problem, this rule also says that plastic waste, which is recovered, which is after decontamination and mutilation, should not be sent to the landfill. Now, there's another bag in biomedical waste management rules, which is white colored bag, and preferably, to the extent possible, it has to be translucent, where you can see what is inside. But it should be sufficiently also strong so that it doesn't get punctured while storing the waste. And what it is supposed to store is mostly the sharps, including metals, which are used in healthcare facilities. Example of these sharps, needles, syringes, surgery blades, scalpels, broken ampules, anything which can actually cause injury and has to be managed carefully is basically sharp. And they need to be stored in puncture-proof, leak-proof, tamper-proof containers, which should be white in color and preferably translucent so that you can see through. Treatment procedure prescribed is autoclaving or dry heat sterilization, followed by shredding or mutilation, or encapsulation in metal containers or cement concrete. And since they don't have any calorific value, they are mostly metal parts. They need to be sent to not for recycling, but for the recovery of metals if it's mostly metal. And the rule says that they can be sent to iron foundries in the region where there are iron foundries for melting such steel. But these iron foundries should have authorization from State Pollution Control Board for melting them. So here also the emphasis is on the recovery of resources, but after disinfection and after mutilation. And if there is no metal foundry in the region, then they can be sent to landfill site, sanitary landfill site, but only after proper disinfection. Then there's another bag, which is blue colored. And what that needs to store is basically glasswares, broken and discarded contaminated glasswares, including medicine vials, ampules, except those contaminated with cytotoxic drugs. Cytotoxics, as I said earlier, is too toxic to be stored in such containers. It only goes in yellow bags if it is cytotoxic drugs. They can be stored in cardboard boxes with blue colored marking so that one knows that these are mostly glasswares which are generated. And they can be disinfected by soaking and washing glass waste and cleaning with detergent and sodium hypochlorite treatment, or through autoclaving and microwaving or hydroclaving. And then this glass can be sent for recycling. But here you don't require authorization for recycling of glass, so any glass recycling facility can pick up this, but only after sterilization. In this, another category, metallic body implants. Sometimes you also generate metallic body implants in surgery and all. When you remove these, they also need to be stored in cardboard boxes with blue colored marking. Now there are certain, this was about the type of containers, which I'll also discuss after the slide, a summary how these containers look like or bags look like. In addition to these containers, all these containers should have proper labeling, and the vehicle which is transporting or is used for interim transport should also have proper label saying that there's a biomedical waste which is packed inside, or there's a biomedical waste which is being transported. Even the common facility should also have this label which indicates that it's a biomedical waste which is being managed. So first label tells you that it's a biohazard, and this has to be fixed on any facility which is managing biomedical waste or container which is storing biomedical waste. In addition, if you are also handling cytotoxic drugs, then additional label which has to be placed on such containers is cytotoxic hazard symbol, which is a triangle and a white C inside, which indicates that it's a cytotoxic drug containing container. Now, packing and disposing of biological waste. Sometimes there are certain do's and don'ts. For example, in the first figure, when you see, what is not prescribed is do not use interlocking flaps. Fold opposite flaps and tape the bottom and top so that they don't leak and they don't leak the waste. Fold flaps to the outside of a box when you open the boxes. Line box with red bio-waste bag. Put your waste inside, cover it, then close it. If it is a red bag, a red container which is going in for transportation. Another, if you look at second row, another important consideration, in the red bag, do not put sharp because they will puncture and cause injury. Also, don't try to pack the bag, push the bags inside with the feet or hand and use proper blocks for pushing them inside so that you don't get exposed to container and also don't cause any damage to integrity of the container. Sharp boxes, if you look at second row last block, sharp boxes must be labeled with site address so that we know that from where they are generated, and also a QR code. To seal the third row, use proper taping, and then this bags go in cardboard boxes, and then they, as shown in last photograph here, H-shaped taping has to be done so that the required information also can be printed on the bag. There's some empty areas where you can put in required information, for example, name, location, phone number in case someone has to be contacted, and also date on which these bags are packed and due for transportation. So these are some kind of common do's and don'ts for packing and making waste ready for transportation. Waste collection. Waste collection, if you look at the slide on the photograph on the left hand side, normal common waste, which is municipal solid waste, can be collected in such trolleys where you don't require color codes and you don't require biohazard symbol. But for biomedical waste, you have to have a biohazard symbol as placed here, and also requisite information on these particular type of waste, whether it is a red bag or blue bag, a blue container or a white container or a yellow container. Now, this basically summarizes what was for your easy understanding. It summarizes what the Schedule 1 prescribes on for the requirement of different bag types or container types, and also shows you how these bags and container look like with all the labels and prescribed information. So yellow, capturing again human anatomical waste, animal anatomical waste, soiled waste, which is contaminated waste, discarded or expired medicines, chemical waste, chemical liquid waste, but not in bags, in containers, and has to be separated, collected separately, not mixed with solid waste. Discarded linen, mattresses, bedding contaminated with blood and body fluid, and microbiology, biotechnology, and other clinical waste. Red bag or red container, contaminated waste, which has to be disinfected and can be sent for recycling. White, as I said earlier, waste sharps, including metals. Blue, glasswares and metallic body implants. Treatment options, as I briefly discussed, but again, the rule also prescribes treatment options. For yellow bags, incineration, plasma pyrolysis, expired cytotoxic drugs returned back to manufacturers to the extent possible. If it is not possible, then incineration or plasma pyrolysis. Chemical liquid waste should be pre-treated and then sent to ETP to conform to Schedule 3. Non-chlorinated chemical waste disinfection followed by incineration or plasma pyrolysis for energy recovery. If the waste has high calorific value, then they can be also used for energy recovery. Pre-treat or sterilize waste with non-chlorinated chemicals, because in these cases, in yellow bags, commonly used disinfectant, which is hypochlorite, should not be used, sodium hypochlorite, because it contains chlorine. So you have to use non-chlorinated disinfectants like ozone or hydrogen peroxide or some such disinfectant, which is not containing chlorine, because they need to, ultimately they will go for combustion or incineration, and they should not generate any chlorinated, chlorine-based emissions. Red bags, autoclaving, microwaving, or hydroclaving, followed by shredding or mutilation, or combination of sterilization and shredding. But a red bag should be preferably going for recycling or energy recovery and should not be sent to landfill. White, autoclaving, dry heat sterilization, followed by shredding and mutilation, or encapsulation. Sometimes you encapsulate the containers in cement matrix and send it for disposal so that they don't leach out anything. If there is a foundry available in the region, then autoclaving and disinfecting and send it for foundries for recovery of metal. Otherwise, to sanitary landfill if there is no foundry available. Blue boxes, disinfection by soaking. Washed glass after cleaning and recycling. Here you can use sodium hypochlorite because these are not going for incineration, and disinfect them and send for recycling and recovery of glass. There are some do's and don'ts also for segregation, packing, and transportation. The summary of this is no untreated biomedical waste should be mixed with other waste. And why is that? Because I said that you don't want to unnecessarily increase the amount of biomedical waste. Preferably, you will, by good segregation practices, you would like to keep it to 10%, 15% of the total waste generated in a healthcare facility. It should be segregated, prescribed containers should be used, and Schedule 1 describes that. Containers or bags need to be labeled, and these labels are given as I showed you earlier. Schedule 4 provides these labels, how these labels should be printed. Barcode and GPS, as I said earlier. And similar vehicles and the vehicles which are transporting the waste should also have labels as prescribed in Part A of Schedule 4, so that necessary information can be gathered from the transport vehicle itself if there is a problem of tracking the vehicles. Now, all the transportation, since you are transporting the waste which is essentially toxic or infectious in nature, it has to be transported as per Motor Vehicle Act rules. Motor Vehicle Act, why Motor Vehicle Act rules? Because Motor Vehicle Act rules actually also prescribe how hazardous chemicals or hazardous materials should be transported and what are the care, how they need to be tracked, how what should be done in case of emergency. Say some accident happens, say some leakage happens, who should be informed at the district level, district collector, police, nearest police station, and all that. All that information needs to be provided in the transportation vehicle. An emergency contact number also needs to be provided. Untreated, as I said, touched this earlier as well. Untreated human and anatomical waste, animal anatomical waste, soil waste, and biotechnology waste. Essentially, these are some waste which have to be packed in yellow bags. Should not be stored beyond 48 hours in a facility where these wastes are generated. And within 48 hours, they need to be they need to be packed and transported to biomedical waste treatment facility. Key features of these rules also, there are certain issues. Conduct health checkup and at the time of induction and at least once in a year for all health workers and others involved in handling biomedical waste rules. So these are some new features which were not there in earlier notifications. Existing incinerators, because what happened was when these rules were notified, since the rules essentially initially were notified in year 1998, and since then many common biomedical waste treatment facility had come, and also a lot of hospitals, the larger hospitals, for example, AIMS in some areas and larger hospitals, they had installed their own incineration facilities. But when these incineration facilities were inspected, it was observed that they're not burning the waste in desired temperature regime, so that complete destruction of waste takes place. And often they result in emission of unburnt, uncombusted waste. So that was becoming a problem. So this has been now taken care of in the rule of 2016, where it says that all the existing incinerators which were operating before the rule will have to retrofit themselves for correcting for retention time in secondary combustion chamber and with the respect of release of dioxins and furans within 2 years of notification of these rules. So all these facilities, most of these facilities have now been retrofitted so that they don't result in unnecessary pollution while incinerating the waste. No occupier, also important aspect is no occupier shall establish an on-site treatment and disposal facility if there is a disposal facility, common disposal facility available at a distance of 75-kilometer radius from the facility. So that puts restriction on each hospital and healthcare facility installing their own treatment facility. Because why this is done? Because of the very reason that if they are lesser facilities, larger facilities, then they are easier to monitor by state regulatory agencies. If they are dispersed and small facilities, then they are very difficult to monitor practically for their efficiency or how they function. Maintain and update day-to-day basis the biomedical waste management register and display monthly record for the generation for the occupier and for the treatment on the website of the treatment facility. So they need to basically also disclose how much waste they are receiving or treating every day on a monthly basis, and also the generator also needs to disclose that. Information typically to be collected. This is a form which is appended to the rules. How much waste is generated on a kg per day basis of in yellow, which will go in yellow bag, red bag or white bag or blue bag, and what is a prescribed method of treatment and disposal which the common waste treatment facility has, and that needs to be filled in this and needs to be submitted on a monthly basis to State Pollution Control Board. Now, these were all important part of the regulation, as per which if these facilities are monitored, then there should be very little problem of biomedical waste facility management in the country. Subsequent slides basically capture now what is happening. This is status which is compiled by Central Pollution Control Board, and they have come out with a kind of status report as per 2017. What is the status of these biomedical waste facilities in the country, and also how much biomedical waste is generated. So as of total number of healthcare facilities as per this report were around 2,38,259. Number of bedded healthcare facility, because bed is actually very crucial in terms of generation of biomedical waste facility, and it is kind of estimated that every bed in hospital generates around 0.25 kg of waste every day. So estimate waste generation from healthcare facilities can also be estimated based on their bed capacities. 100 bedded hospital or 250 bedded hospital or 500 bedded hospital. There's a thumb rule that number of beds multiplied by 0.25 will give you an estimate of how much biomedical waste this hospital would be generating. But also important are, since the rule also cover non-bedded facilities, number of non-bedded healthcare facilities around 1,51,000. Number of beds which are available. Number of common biomedical waste treatment facilities 198 plus 28 which were under installation. And number of hospitals or healthcare facilities which have captive treatment facility, mostly autoclaving, microwaving, and incineration, around 9,800. Number of captive incinerators which are there in these healthcare facilities, around 225. Quantity of biomedical waste generated every day, 559. Quantity of biomedical waste treated, 518. So, I mean, still there's some gap and some still escapes untreated. Number of healthcare facilities which at that point of time violated biomedical waste rules were around 23,900, 24,000 roughly, and around 18,000 of them were issued show cause notice. So this is summary of how CPCB tracks the implementation of these rules. This gives you a status of how number of common biomedical waste treatment facilities have grown over the year, and now more or less have become established at optimum capacity of around 200, and another 24 will be added in due course. So as I said, generation stands to around 559 tons per day, of which 78% is treated and disposed in these biomedical waste facilities, around 198 of them, and rest is treated in captive treatment facilities, which are present in these healthcare facilities. And there are 225 captive incinerators available in these captive facilities for finally incinerating this waste. CPCB has also come out with guidelines for establishing these common biomedical waste treatment facilities, which were also reduced in 2016 along with these rules. So first time the guidelines were introduced in 1998 along with the earlier rules. Then they were revised in 2016. They are applicable to all the healthcare facilities which are located in radius of 75 kilometers by road. They can also be developed as part of like many, I mean, if you are familiar with industrial waste, what happens is for managing hazardous waste generating from industries, you need to establish something which is called TSDF. The way it is different from common biomedical waste treatment facilities, that the TSDF stands for treatment, storage, and disposal facility for hazardous waste. If there's a common hazardous waste facility, and if the same operator wants to also establish a common biomedical waste facility, it can establish that, provided there is no such facility available in 150 kilometers. So biomedical waste facility can coexist with hazardous waste facility, provided there is no common facility available otherwise in 150-kilometer radius. Minimum recommended plot size for establishing common waste treatment facility will be 1 acre. It can be reduced to 0.5 acres if the common facility decides that it will not release any effluent and it will reuse all the effluent which is generated after treatment of wastewater. ZLD here stands for zero liquid discharge. So if the unit is zero liquid discharge, then it can also be established in 0.5 acres. Otherwise, you need to have a minimum plot size of 1 acre. Coverage criteria, the common waste facility should cater to at least 10,000 beds in the area and up to 150 kilometer if the waste can be transported within 48 hours of generation from the healthcare facility. So these are kind of important guidelines which decide on how waste needs to be transported. This gives you a kind of layout arrangement and how these boxes need to be stacked in a vehicle in a manner that while transportation they don't kind of fall over each other and they're not kind of damaged by transportation. What is not seen here is the important aspect here is these vehicles are such designed that they have rubber cushion in the bottom to absorb the shock so that the vehicles are not waste is not damaged. If the waste what is also clearly seen here in the next photograph is how these containers are then to be locked and how these labels need to be displayed so that while transporting this waste, one very clearly knows that these are transporting biomedical waste to the biomedical waste treatment facility. These are some of the PPEs which are not only required to be used by occupier, which is generating biomedical waste, but also the workers at the common biomedical waste treatment facility. Gloves, goggles. If the worker is working in shredding area or incineration area where the noise level is more, then earplugs. If worker is also working in infection area, then suitable mask to protect him from infection. Helmets, face shields. Face shields have now become very important in the COVID times as well. And then coveralls also have become very important in COVID times. This is a schematic of some common biomedical waste treatment facilities. The first photograph is kind of layout of an incinerator and how waste has to be basically transported and fed into incinerator after the pre-treatment. And then a kind of autoclaving facility, how waste can be fed to autoclaving facility for disinfection. Storage facility is also very important in the common biomedical waste facility, and the waste has to be stored in a segregated manner. For example, the shed outside, there's a label saying that this is a storage facility for biomedical waste, and inside there is a segregated chamber, yellow and red and other, for storing these waste in a segregated manner so that the waste operators know, they don't accidentally mix the waste while treating this waste or sending it for disinfection and treatment. In the earlier, I said that in remote areas where you don't have waste treatment facility, for the anatomical waste, for infectious waste, which is supposed to go in yellow bags, for the rural areas, rule has recommended that you can pre-process them, disinfect them, and then you can put them into such burial pits. And this burial pit should have actually, they have also prescribed the dimension for this burial pit. And at the bottom, there should be bottom clay layer so that anything which is leaching, it should be concreted pit to the extent possible. If it can be concreted pit, otherwise you can put even earthen pit if the finances don't agree. For that, you need a bottom clay layer. Above that, you can every day on the generation, you can keep disposing your biomedical waste and covering it with a soil layer every time you dispose of biomedical waste till it gets full. And then you need to basically stop disposing and put a cement barrier and cover it with soil and close it. Once one pit is full, then you can go for next pit in the area. And because what happens is, most of the time, for practical purposes in rural areas, remote areas, these facilities will not be available, and infectious waste cannot be left in environment, so that people are not affected by this waste. There's also CPCB also has given location criteria for these common waste disposal facilities. A location criteria has to consider these aspects and has to prevent these aspects from happening. For example, it has to address potential for spread of infection from waste stored in the premises. It has also to adhere to applicable standards for pollution control and efficiency for treating waste, efficient treatment of waste by incineration or emission control system. Potential, it has to address potential of fugitive dust emission from incinerator, potential for discharge of wastewater, potential for odor production if waste is infectious and also decomposes over the time, potential for addressing noise pollution, risk posed to human health, safety due to exposure to emissions from incinerator, risk of fire, and risk of residual impacts like from treatment of when you're incinerating waste, there will be also generation of bottom ash and fly ash. So that also needs to be managed in a manner that they don't have impact on the surrounding where they operate. This slide essentially gives you, when we talk of autoclaving, microwaving, or different sterilization, what are the standards you need to follow, and to what standards you need to treat them, and what is the frequency which you need to follow. Say, for example, autoclaving once in a 3 weeks, you also need to check their validity once in a 3 months, so that your autoclave which you have installed is working properly or not. And you also need to check if you're using different tests and different frequencies. If you're using biological indicator test, that once in a 3 months you should check the validity of your test. If you're using paper strip, chemical strip, then once in each batch you need to test. Microwave, if you're using biological method, once in a 3 months. If you're using chemical treatment method, then you should test validity once in a week. Dry heat sterilization, again, once in a 3 months. If you're using chemical indicator, then once in a week. Plastic waste after recycling, after disinfection shedding, what are the different options which one can use for utilizing plastic waste? You can send them to registered authorized recycler. Send it to a facility where they can be used for energy recovery. For example, now a lot of cement kilns, if they are in the vicinity, they can use it for as a fuel in the cement kilns. For diesel or fuel oil recovery, waste can be, this waste also can be pyrolyzed and can be used for fuel recovery. For road making, in case if nothing is possible, then if the new roads are being constructed, you can mix them with, after shedding, mix them with bitumen and lay the road. For sharps, essentially, it has to go for either iron foundries or waste pit. We have discussed this earlier. Oil and grease, which is generated in the facility, has to be managed by incineration. Now, the liquid waste, which is generated in ETP, if that is treated, which is treated in effluent treatment plant, they need to be, they will generate a lot of ETP sludge. So the sludge either has to be disposed after drying at the common waste treatment facility itself, if it has a space. Otherwise, it has to be sent to hazardous waste treatment and disposal facility, which also maintains a landfill. Hazardous waste, as I said earlier, has to go to hazardous waste treatment disposal facility. And this is guided entirely by a rule which is called Hazardous and Other Waste Management and Transboundary Movement Rules, which were also notified in 2016. This is a guideline for environmentally sound management. ESM basically stands for environmentally sound management of mercury, because mercury is one of the very toxic heavy metals which also gets generated from healthcare waste. Mercury is used in different equipments, different, say for example, dental amalgams also is using mercury. Though we are trying to now phase out mercury, because India is also signatory to Minamata Convention, which is an international convention, where India has also agreed to phase out mercury, use of mercury. Mercury can be released in air. Why mercury is a problem? It can get released into air in patient area or into wastewater stream due to spillage in working environment and ponds. Release in environment by medical waste incinerators due to burning of medical waste mixed with mercury. Disposal of mercury containing medical waste including dental amalgams. Sometimes it also comes from thermometers, blood pressure equipments. If you dispose them without pre-treatment, which is stabilization or solidification, then also mercury can get released. So what is environmental sound management practice recommended? Use alternatives which to mercury. For example, a lot of now electronic thermometers, electronic blood pressure measuring device have come, which Government of India is also committed to replace use of mercury in a phased manner, which is also following up Minamata Convention, as I said earlier. Spill management by collecting and amalgamating mercury before its disposal. Storage of mercury-bearing waste in a proper manner so that it doesn't contaminate any area. And mercury recovery. There are mercury bulk manufacturing facilities in the country which still have got mercury recovery facilities. They can also be sent to for mercury recovery at those facilities. These are some issues why sometimes medical waste management still remains a problem. Just a second. Hello. I'll make a presentation here. I'll call you back after the presentation. Sorry. What happens is these healthcare facilities, many times they don't submit annual report in a timely manner. Even common waste facilities, they don't submit their annual reports in a timely manner. There are many healthcare facilities which still operate without authorization because it's very difficult to track every healthcare facility. Certain states and union territories still have to develop common biomedical waste facilities, which are now in the process. And installation of there's something called SEMS. SEMS stands for Continuous Emission Monitoring System, where these facilities can be monitored on a continuous basis by automated monitoring, and these results can be directly sent to State Pollution Control Board, so that on a daily basis they can verify if these facilities are working properly or not. So this has also started happening now for biomedical waste facility. For industrial waste, it started much earlier. Now for biomedical waste facility also it's starting. So once these SEMS get installed, then monitoring these facilities will be much easier. As I said, mercury waste management still a problem, but Government of India is committed to phasing this out. Biomedical waste, since veterinary hospitals were new entry, which were notified in 2016 only, this is still a problem in veterinary hospital because they still, a lot of training and capacity building required for these people to understand the implication of improper management of biomedical waste facility. So what I'll do is I'll stop here, and because we have 20 minutes left, I would like to spend that in question and answer, and maybe at some other occasion we can discuss framework for hazardous waste. And in case if there is a session in hazardous waste separately in the session, I think that would anyway cover all these issues. So over to you, Professor Thakkar, if there are any questions, if there are any queries or.
Okay, thank you, sir. If anyone is having any kind of query or question regarding the topic, he or she is free to ask the question. Yes, anyone having any kind of questions or queries?
Yes, sir. I have one question.
Yes, yes.
Sure, go ahead. Sorry.
Yes, sir. Sir, how the plasma pyrolysis is different than the first pyrolysis?
How you said how plasma pyrolysis is different than uh, normal
First
pyrolysis?
pyrolysis. Yes,
The
sir. Yes.
pyrolysis process essentially is, carrying out waste combustion in a controlled manner, where in a normal pyrolysis process, you basically generate oil as a intermediate product, oil as a product. In plasma, same thing, similar operation is done at a much higher temperature where you generate plasma. And this plasma arc actually generates much higher temperature and uh, treats waste. The waste product which comes out in plasma pyrolysis is completely vitrified product. It's a glass-like residue which is completely inert. In plasma, in normal pyrolysis, you generate a pyrolysis oil, which is a fuel, which is a resource. In plasma, you generate both have different end products, but energy recovery can be done in both processes. One through oil, and in one through waste heat, which is generated. Plasma. The only problem with plasma is much more expensive than normal pyrolysis process, because you need to have a refractory setup for generating plasma and operating plasma at much higher temperature. So, and many times if your waste is not homogeneous, managing plasma pyrolysis in a sustained manner on a longer period becomes a problem. And if there is a breakdown in plasma pyrolysis, then the repair and maintenance is very expensive.
Yes, sir.
Is that fine?
Satisfied.
Yes.
Thank you, sir.
Sure. Welcome.
Okay. Any other participant having any kind of questions? Yes, anyone?
Good morning,
Okay,
sir.
then.
Mahavir bol raha
Good morning.
Yes, Mahavir, continue.
Go ahead.
hu. Sir, may I just question for that? I have my project in downdraft gasification. Uh, that wastage, which type of wastage are need use for high efficiency for that downdraft gasification?
Say it again. What is the feedstock for your gasification?
Which type of feedstock used in very highly used in that feedstock type of wastage?
See, basic principle of gasification is that under controlled combustion, in absence of most of oxygen, at much lower temperature, you generate something which is called producer gas. Okay, and producer gas is mixture of carbon monoxide, hydrogen, and some amount of very little amount of carbon dioxide, which is much cleaner actually to use as a fuel. If you're, say, for example, if you're gasifying coal, or if you're gasifying plastic or solid waste, the producer gas which gets generated is much cleaner in terms of sulfur content or particulate, and it's much more efficient to use producer gas than actually using the original fuel, burning coal directly or burning woody biomass directly or burning waste directly. The flip side is that the tar which gets generated while gasifying and recovering the producer gas is a challenge and has to be managed properly.
Okay, sir. Sir, can you tell me what type of different type of food, different type of wood are used in feedstock?
See, general thumb rule is that the moisture content in the wood feedstock should be minimum. Because if the moisture content is high, then some amount of energy you will waste in drying the waste. The wood which is obviously you would like to use wood which is having least commercial value. You will not use wood which has got commercial value. So any biomass, for example, in a lot of places where the forest cover is good, or where tree cover is good, a lot of hard woody biomass gets generated time to time, which has very little value. So that can be very safely gasified and used as a fuel.
Sir, can you explain in brief the importance of PPE in waste management?
Yes, I mean, what happens is PPEs, as the name suggests, personal protective equipment, is basically meant for protecting people who are working in that area, either handling the waste or storing, help in storing the waste or transporting the waste or actual treatment of waste. They help protecting the worker from exposure to waste material. So one is, while handling, you should wear proper gloves, which are not compatible with the waste, which don't react with the waste. You should have proper goggles to protect your eyes. There are safety goggles available. In case you are moving in such area where you expect waste also to be lying on ground, then you should have proper gum boots. Otherwise, proper hard boots, so that you don't interact with that. And if you are working in, say, very sensitive laboratory area where infection in air also is possible, then proper overall, proper respirator, and also if it's a noisy area, then proper earplugs or earmuffs to basically contain noise. So whatever aspect is important in that area, your PPE should be designed to tackle that particular aspect.
Thank you, sir.
Is that clear? Yeah. Welcome.
Thank you, sir.
Welcome. Welcome, Marvin. So anyone else? I think that is all, Professor Thakkar, or if Professor Thakkar, are you there? Hello, am I still audible?
Hello. Now
Hello.
my audio is coming, sir.
Yes, it is.
Hello.
Yes, it is coming. I can hear you.
Okay, sir. Okay, sir. Okay. Yeah. So on behalf of the Mechanical Engineering Department, ADIT, I would like to thank the Dr. Sunil Pandey, sir, the Director of the Environment and Waste Management Division, first for accepting our invitation in just a single mail, and for delivering such a nice talk on the biomedical waste management, which is a really important part in this pandemic situation, where suddenly we have seen growth in the usage of biomedical equipment. So their disposal is definitely one area in which we need certain concentration and focus. Sir, you have covered the presentation very nicely. You have started from the fundamental aspect, different acts, how to say categorize different biomedical waste, and what are different ways to handle different forms of biomedical waste. It was really good presentation, sir. I'm sure it would be definitely a fruitful one for our participants. Thank you very much, sir. From the entire Mechanical Engineering Department, ADIT, we'll also look forward to have you in another such kind of programs. Thank you very much, sir.
Sure, pleasure is mine. And just to add a small point, now in times of COVID, what is happening is in many areas, the waste generation is much more than this common biomedical waste
sir.
we can handle. So what's happening is CPCB has also allowed the industrial waste incinerators to handle the extra amount of biomedical waste generated in COVID times. So that, they are not thrown here and there, and they are properly incinerated.
Okay, sir. Okay.
My pleasure also to interact with you all, and I hope to continue this interaction in future as well. Thank you so much.
Sure. Thank you very much, sir. Thank you. To the participant, I would like to convey that our next session will be on